Okay, so let's go through the remainder questions for this paper, right? For functions and graph. Okay, so let's look at this question here. So now your whole equation, right, is y equals to x squared over 6 plus 3 over x. The corresponding values of x and y are given in the table, correct to one decimal place. Okay, so they ask you to calculate the value of q. Okay, so just use your calculator. Y equals to 5 square over 6 plus 3 over 5. So you take out your calculator, you just key 25 over 6. 25 over 6 plus 3 over 5. Okay, one decimal place, you should get 4.767, 4.8. Okay, so Q is actually 4.8, right? Okay, now on the same axis, graph. Okay, so you need to draw the graph. What I did was I actually used the graph is given for you for this one. Okay, write down the coordinates of points of intersection between y equals to 1/4 x plus 2 and this one. Okay, so we need to draw the line of y equals to 1/4 x plus 2. So we can choose any 2 points here. Now, given that the denominator is 4, right? So let's try 4 and 2. Okay, to see whether we can get a nice number. So for here, let's draw the table again. So this is a straight line, right? So we get x and y, 2, 4. So when x equals to 2, okay, when x equals to 2, y equals to 1/4 2 plus 2. So divide, you should get 2.5. Right? Then when x equals to 4, y equals to 1/4 4 plus 2, 1. Right? This whole thing cancel. Equals to 3. Okay, so you should have 2.5 and 3. So if you want to find the x coordinates of points in this section, we need the plot. So 2.5, we're going to use this one. When x is 2, y is 2.5. So this is my first point. Okay. Then the next one is when x is 4, y is 3. When x is 4, y is 3. Okay, so you roughly draw. Okay, let's see how my drawing goes. Like this. Okay, please use a ruler. I don't think I can draw a straight line here because the thing will always run. You see, let's see if it works. Oh, okay, it works. Okay, so we try to draw and extrapolate the line, so that it goes beyond. So let's see if I can get a roughly straight line. Yes. Okay, well done. Okay, so from here, find the value of x of the intersection. So 1 is around this point here, right, in between. So I will get around, go all the way down, 3.45. Right, 1, 2, 3, 4, 5. 3.45. Okay, then if I draw another point here, this one is easier to see. This will be 1.245. Okay, so the values are around 1.5 and 3.45 for this question. Okay, so write down the coordinates of x. So x answer, x equals to 1.5 or x equals to 3.45. Okay, find the equation in the form of 2x cubed plus x 2x squared, which can be specified by the values found in part E. Part E. EF. Okay, so I'm not sure if there's a mistake in the question. There's no E. Right, so can't really do F. Okay, never mind. So we'll skip this first. Okay, find the gradient of a curve when x equals to. Okay, so I've drawn it here. This is the gradient. Okay, it must just touch this point. Right, so I can't mark out 2 points that I can find your whole number. So this would be, let's say I take this point. Okay, so let's say I use red color. So this point would be x is 1, y is 2.12, 2.2. Okay, then down here is x is 4, y is 2. Okay, see 1.1. Okay, so let's label it 0.1, 0.2, right? So 0.1 would be 1, 2.2. Okay, so let's take 0.1. Okay, 1, 2.2. And then 0.2 is 4, 2, right? 4, 2. Okay, so we want to find the gradient. So gradient m, y2, right, y2 which is 2, minus y1 which is 2.2, over x2, 4, minus 1. So we will get minus 0.2 over 3. Okay, so that works out to 0.2 divided by 3. So I will get minus 1 over 15. Okay, so yeah, so around there, because the line is relative, the gradient is almost right at the bottom. Okay, but it's slightly negative because my line is going this direction. Okay, so my gradient is negative. Okay, so this is how we complete this question. Okay, let's move on. Right, so now you will learn about graphs of exponential functions. So you will see exponential is like y a to the power x. Okay, so you notice it goes up here. It doesn't even go through the origin. Okay, so likewise, this is when x is more than 1. A is more than 1. Okay, but this one is when k is more than 0. So it's positive k, it goes up. Negative k, it goes down. Okay, alright. Even though both a are more than 1. Okay, so we have this question, right? So we don't have a k yet. Our a is 1.5. Right, so they ask us to find the values of a and b. So just submit the values again. So a equals to y, which is equals to 1.5 to the power of 4. Okay, so all is to 2 decimal places, 1.5 to the power of 4. We will get 5.0625, round off 5.06. And you get b, which is also 1.5 to the power of 6. Okay, so 1.5 to the power of 6. 11 over 39. 11.39. Okay, so moving on. You're supposed to plot your graph. Okay, then use your graph to find the value of y. Okay, so what I've done is I use GeoGebra to create this one. But you need to draw it. Okay, this graph is you need to draw. Alright, so y, find the value of y when x is 6.4 and y is 3. Okay, so let's do y when x equals to 6.4. 6.4 will be around here. Okay, so the problem with GeoGebra, it couldn't really cover everything. So Oh, yeah, so it's very hard to screenshot this part. So 6.4 will be all the way up here. Alright, so based on, okay, let's go to GeoGebra instead. Okay, GeoGebra. Okay, graph. Okay, so I wasn't able to screenshot everything, so let's just key y equals to 1.5 to the power of 1.5 to the power of x. Okay, 1.5 to the power of x. Okay, so let's see what we get. 1.5 to the power of x. Sorry, x. Okay, so from here, if we look at it, 6.2 goes up here. So by right, 6.2 will coincide with this point. Okay, which will give us 13.6. Okay, can you see? It should be this point. 6.2. Okay, so 6.2 should be around here. Alright, this point. Okay, so we roughly should get 12.4. Okay, 12.4. Alright, but you draw the graph and see what you get. Okay, so but I'm just going with 12.4. Okay, so from your graph draw, mark out y equals to 12.4. Okay, because this picture was not capturable on GeoGebra. Okay, but we can check x when y equals to 3. So when y equals to 3, okay, you notice it goes down midway. So it should be around 7.2467. Okay, so x equals to around 2.6. No, 2.7, sorry. 2.7. Okay, so by drawing a tangent, find the gradient of the curve at x equals to 5. So x equals to 5 will be here. Okay, so we need to draw a tangent. Okay, let's see if I can get from here. Just nice touching here. Okay, not possible. Okay, so let's see if I can get around here. No, also not possible. Okay, so your tangent has to just touch at that point. Okay, just touch at that point. Okay, so let's try this point. All the way here. Okay. Okay, so I was aiming for this point here. Which would be around 5.8. Okay, this will be around 5.8 and 10. Okay, and down here would be around 4.2 and 5. Okay, so I'm going to call this point 2. Okay, let's call this point 2, point 1, right? Point 2, point 1. Okay, so point 2 is 5.810. Okay, and then point 1 is 4.25. Okay, so your gradient y2 minus y1, 10 minus 5. Then 5.8 minus 4.2, 5.8 minus 4.2. So you get 5 over 1.6. 5 divided by 1.6, you get 3.125. Okay, so you find the gradient at a curve by just drawing a tangent that just touches that curve. Okay, it's quite hard to do it on the iPad, right? So hopefully you can get a better result than mine. Okay, then finally the last question for today. You have this equation y equals to 50 times 2 to the power of t. Okay, so find the value of s. S is here, s is y, when t is 4. So 50, 2 to the power of 4, if you use your calculator, it should be 800. Okay, so this one should be easy to draw. Okay, so if you go down, okay, I wasn't able to use GeoGebra to draw this because the numbers are too big. Okay, so 0 is 50, so it's 1, 2, 3, 4, 5. Right, so from here, okay, 100, 2, 200, 3, 400. 100, 2, 200, 3, 400. Okay, you notice it curves upwards. Then the last one is 800. 800 here. Okay, so you should get roughly, okay, I'm not too good at drawing on the iPad. Okay, I think decent effort. Okay, so give or take. Okay, you should use a curve ruler. Please don't use freehand if you're not good at it. Okay, so estimate how long after the first infection if there are 500 zombies. 500 zombies will be here. Okay, so my estimate is going to be off because my curve is really bad. So it's like 1, 2, 3, 4. Okay, 3.5. This is the midpoint, right? So 3.5, so 3.4 hours. Okay, 3.4 hours. Okay, estimate how long? T equals to 3.4 hours. Find the gradient graph at 2 to 200. So 2 to 200 is around here. Okay, again, I can only show you the method. Okay, my results are way off. Use your ruler. Okay, let's see if I can get this. No. Okay, try again. Okay, so it's not going to jump again. Okay, so let's see if I can get this done. From here maybe. Okay, never mind. Let me just try to use freehand. So I'm going to try here. Draw a line, rough line. Okay, please use a ruler. I can only show you the method now. Your y is 1.2, 1, 2, 3. 1.3, 100. Okay, and then down here is 2.8300. Okay, so I have this is 0.2, 0.1. Okay, so again, back there, the method 0.2 is 2.8, 2.8300. Okay, 0.1 is 1.3100. Okay, 1.3100. Okay, so your gradient, now this, my answer is totally off, but the method is correct. It's just that I don't have to, I'm not able to draw a straight line. Okay, so 2.8 minus 1.3, 200 over 1.5. Okay, so 200 divided by 1.5 is, okay, we're gonna use fraction 133 and 1/3. Okay, quite extreme. Okay, explain what does the graph at point 200 represent. Okay, so the graph actually shows the rate of the zombie increasing. Okay, so it's kind of like saying that at this point the rate of zombie infections is increasing by 1.33 and 1/3 per hour. So the gradient, okay, at point 2,200 is the rate of infection. Okay, so at that point you are seeing 133, around 133 zombies appearing per hour. Alright, okay, so give these graphs, go and draw these graphs, go and complete it. Alright, then I want to check in class. Okay, we'll stop here for now and we'll do this on Wednesday. Alright.